Hey everyone, it's week 3. I can hardly believe it myself, but here we are at the beginning of week 3, and the topic this week is DNA, one of my very favorite subjects of all time. This is what I did my PhD research on and what I've been interested in forever. So DNA is the molecule of heredity. It determines the characteristics of any organism. Every characteristic that an organism has comes from the information found in DNA. So this week we're going to explore DNA. I have a few applications for you and I think a few things to mention before you get started. In the news in at least the last 6 months, there's been a lot of controversy about something called a three-parent child. So I did want to mention this because last week you learned about organelles, and a lot of you talked about mitochondria. Well, sometimes people have mitochondrial diseases. And the problem with this is, if you're a woman, you will pass that disease to all of your offspring, because every child that a woman produces comes from her egg. And the egg contains all the cellular machinery, all the organelles of this fertilized egg. So, if you're a woman with a mitochondrial disease, you can prevent the transference of this disease onto your offspring by using a donor egg. And I have a diagram of it right here. And so this is why they call this a three-parent child, because you've got an egg donor, you have a mother, biological mother, and biological father. So let's see how this works. So the egg donor donates an egg, and then the nucleus is removed from that egg. So all you have is the cell machinery now. The biological mother, you take her nucleus, because that is perfectly fine, and you put it into the donor egg minus that nucleus. So now you have this hybrid cell. And this is where everybody kind of goes crazy. Sorry about that. But the genetic information from the mother is what is going to determine the characteristics of this child. And then that egg is fertilized with the sperm from the father, and this is what people call a three-parent child. Realize that the genetic information to make that new being comes from the biological mother and the biological father, and just the cell machinery comes from this donor egg. So that's what they're talking about when they say three-parent child. I want to mention the model of DNA, which everyone knows. Oops, here I have a visual. Is a double helix. Yes, it's sitting on my desk. I'm a geek. What can I say? Nerd, dork, whatever. It is the Watson, Crick, Wilkins, Franklin model. The three people at the beginning of this, Watson, Crick, and Wilkins, actually received a Nobel Prize for this. Rosalind Franklin did not, because she had died before the award was presented to them. But she had a tremendous hand in the discovery of the shape of this molecule because of X-ray diffraction, which was her specialty. And so she should be included in this conversation. I want to also mention that the job of DNA is not to just be a molecule of heredity, but the reason that DNA is so important is because of its expression. So what does that mean? Okay, DNA is used to make pieces of RNA and many, many, many thousands of proteins. And the proteins, the proteins determine all the biochemistry that happens in the cell. So all those proteins are what's so important and what determines the identity of any cell and therefore any organism. So the expression of DNA is actually its job, and you have a whole chapter on expression. Mutations, you're going to hear about that quite a bit during this week, and I want to give you a good definition for a mutation. A mutation is a change in the base sequence of DNA, period. Now, it can be a huge change, like you can be missing a whole chromosome or more than a whole chromosome. Or there can be a single base change in the DNA, and those are all mutations. So mutations are changes in the DNA. And what can be the result of this? Sometimes there's no difference in the organism whatsoever. Sometimes there are lethal mutations which cause the death of the organism. And there's everything in between. So you're going to be taking a look at mutations. And then finally, I also want to mention the fact that since the mid-1980s, we have developed this technique called DNA fingerprinting. This is for you guys in criminal justice and everybody who's interested in forensic science. We have this new technique called DNA fingerprinting, where you can actually determine the source of a sample of DNA. And so this is involved a lot of the time in criminal cases where you have some kind of evidence that's left behind, biological evidence, saliva, blood, semen, sweat, there's all kinds of things, skin cells. And you can determine the source of this DNA by doing this technique called DNA fingerprinting. I also have an example of that right here. So the way that you read a DNA fingerprint is it's a column, and you're looking for those dark bands. Those are pieces of DNA. And so here's your crime scenario evidence right there in the first column. And then you have 3 suspects, 1, 2, and 3. And so as you start at the top of the crime scene evidence and you find a bar right there, a band of DNA, you look over to see who has a matching band at that same location, and the location is what's so important. Oops, that suspect 2 has it. What about the second band? Oops, nope, suspect 2, but not 1 and not 3. Those are in different locations. How about the third band? Okay, that matches 1, but that one didn't. Matches 2, matches 3 also. Go down to this big fat band, which means there's twice as much DNA there. Nothing in suspect 1, definitely in 2, not in 3. So you see how this is going to go. So you look at the banding pattern, and sure enough, suspect 2 matches. So that's DNA fingerprinting. So important in solving crimes these days, plus other applications, so many other applications. All right, what do you have to do this week? You need to read your chapters 6 and 7. They're fairly short, but they're packed full of information. And they're all about DNA and the expression of DNA. Your discussion this week is about mutations and how they relate to cancer. So, of course, everyone, all of us have been affected by cancer. In our family and friends, maybe even you have had cancer. So this is going to be an important topic this week. I do want to remind you to fully answer the discussion questions that you have and respond to your classmates, at least 2 of them, by Tuesday night, and ask them pertinent questions. Add to the conversation. Just saying, wow, that was a good read, it was awesome, I loved it, that's not enough in a response to a discussion post. We're pushing the conversation forward about these topics. So ask questions. Or add something that you know about the subject. Or add something that you've read. So make sure you do that. The assignment this week is for you to write up how you would go about describing to a couple who has come in for genetic counseling the particular genetic disease that you have chosen, its signs and its symptoms, how it's inherited. Is it inherited only from the mother? Is it a recessive trait? Is it found on a particular chromosome? Look it up. There's lots of information out there. Look at the National Human Genome Project under NIH, and you will find so much information there. Or the Online Mendelian Inheritances in Man, and it's abbreviated OMIM. You will find a ton of genetic diseases there and all kinds of information about that. OMIM. And also you need to explain why everyone in the family doesn't have this particular genetic disease. That goes right along with how it's inherited. And don't forget to do your quiz number 3. It's very important to do those quizzes. You can stop in the middle of a quiz. Sometimes it works and sometimes it doesn't. If that were me, I would not do it that way, but that's totally up to you. And if you have any questions whatsoever, I love these subjects, so please ask me some questions. There's my email address up there at the top of the page, and I've emailed you this week to talk to you about the discussion post. Ask me questions. Every Sunday night I have office hours from 6 to 7 Eastern Time. Feel free to hop in there and ask me more questions on Sunday night. All right, y'all have a good week, and I'll be talking to you. Bye.